we were talking about was how to find all the various asymptotes. I posted on Classroom the definitions. I didn't print it for you. And so on Classroom I posted all the rules, but for a vertical asymptote, it's x equals whatever makes the bottom 0. And so we talked about, factoring our denominators and listing our asymptotes. And then we went into horizontal asymptotes. And we said we have those in two cases. If the degree on top is smaller, it's automatically y equals 0. If it was the same degree on top and bottom, we divided the leading coefficients. The piece that we ran out of time for was the vertical asymptote, or sorry, the oblique asymptote. So this is posted on that Classroom handout if you don't want to write it all down. This happens when the degree of the top is 1 more than the bottom. So you have like an x to the 4th over x cubed, an x to the 7th over x to the 6th. If the degree on top is 1 more, we have oblique, and to find it, we have to do long division. So that's the piece you need to jot down here. So basically, this idea of our horizontal or oblique asymptote, we're seeing that we can't have both at the same time. For instance, if it was like x plus 1 over x cubed plus 4. I showed you, if you tried to set up that long division, can you do x divided by x cubed and get a whole number? No. So this one, your quotient is 0, and then you have a remainder. So in this case, you have a horizontal asymptote of y equals 0. If it was like a 3x plus 4 over x minus 5, and you set up that long division, what's 3x divided by x? 3. And then after that point, if you did your long division, we're left with 19. Can you do 19 divided by x and get a whole number answer? No. So in this case, it was a horizontal asymptote, y equals 3. All of these rules are really based off long division. I just didn't make you do the long division for these, I just told you what the rule was. If the degree on top is exactly 1 bigger, then we can do it doing long division. So the top has degree 2, the bottom has degree 1. What this means is we have an oblique asymptote. So we will find these by doing long division. What's x squared divided by x? X. And then you multiply. X times x is x squared. X times 3 is 3x. Then what do we have to do? Change signs. You run a negative through. And then when you add, x squared and negative x squared cancel. 2x minus 3x is negative 1x. Bring down the minus 1. Negative 1x divided by x is negative 1. And any work we do beyond this is just to get us our remainder. So the asymptote, in theory, is kind of like saying what it can't be. Since this has a remainder, it's never turns out to be exactly x minus 1. So that is, in fact, our oblique asymptote. You don't have to finish long division. You don't have to find the remainder. Oblique just means it's the equation of a line, so y equals mx plus b. Once you have both of those, that is your oblique. So horizontal asymptote will just be y equals a number. Oblique asymptote, it'll be a full line, y equals mx plus b. So what I want to do first is just a couple problems with finding the oblique asymptote, and then we're going to get into actually graphing these things. Any questions so far? So these were the examples we were doing Friday, or Wednesday, when we stopped. I was just putting some up here and saying find the horizontal or oblique asymptote. And we knew it was all based off degree. What is the degree of the top here? What's the degree of the bottom? 3. So the top is 1 bigger. That tells me it is an oblique asymptote. Now we have to find it. To find oblique asymptotes, it's not a shortcut. You have to do your long division. I'm going to include my zeros. So the numerator goes on the inside, the denominator goes on the outside. The nice thing is when we do these, we're always just going to get a line, mx plus b. You don't have to do the full long division. So once you have those two pieces, you stop. So in doing long division, you start out by dividing the leading terms. What is 3x to the 4th over x cubed? 3x. So that's the first thing I put up here. Then we multiply. 3x times x cubed is 3x to the 4th. 3x times negative x squared is negative 3x cubed. 3x times 0, so we have 0x squared. 3x times 1 is 3x. Now what do we do? Right, we need to subtract. Easiest way to do that, we've always just taught you in Algebra 2 to distribute a negative and then add those things together. So when you do that, x to the 4th drops. 0x cubed and 3x cubed. Add those and you get 3x cubed. Minus x squared minus 3x. You can bring down your plus 0. What is 3x cubed divided by x cubed? 3. At this point, you can stop. You have your slope, mx plus b, that's it. So your oblique asymptote would be y equals 3x plus 3. So we do long division, but we don't have to work the full problem. I don't need the remainder. I just need that actual quotient piece. Questions there? Try another one. So degree of the top, 3. Bottom, so the top is 1 more. Right now I know it's oblique. So we're going to do long division. Start by dividing the leading coefficients. X cubed divided by x squared is x cubed over x squared just turns into x. Multiply, so x times x squared, x times 5x, x times 6. Change our signs. Drop, so we get a 5x squared minus 6x minus 8. So now divide 5x squared over x squared and you get 5. That's all we need. So oblique asymptote is y equals x plus 5. to you a little bit? Would have been nice to have that before the PSAT, wouldn't it? Kind of made me smile when you guys said that was the thing you forgot, because that was what we were going over next. Okay. This one, what's the degree at the top? Degree at the bottom? Okay. If the top is smaller, it's horizontal, y equals 0. If it's same on top and bottom, it's horizontal, we divide leading coefficients. If the top is 1 bigger, it's oblique. If it's more than 1 bigger, then it's none. So this one has no horizontal or oblique asymptote. Questions there? Just exactly 1 bigger. Top is 1 bigger. The last thing I want to mention is sometimes we will get a hole in our graph, and that happens when something cancels out of the top and bottom. So easiest way to make sense of this is just look at an example. If I gave you x squared minus 9 over x plus 3. You could factor the top. How does that factor? X minus 3, x plus 3. And then what happens? Those cancel, and you get x minus 3. So this one, it doesn't actually have a vertical asymptote because that canceled out. What this has is a hole in the graph. It's just like an open circle. Okay, so that you can give me the order pair for that empty circle on your graph. You look at what canceled. What would make x plus 3 equal 0? Okay, so that's the x value. If it hadn't canceled out, that would have been a vertical asymptote on our graph. Because it canceled, that's our x value for the whole. To get the y, you plug negative 3 into what's left. So negative 3 minus 3, negative 6. Okay, so what this graph actually looks like, x minus 3, that's just a line. Y-intercept of negative 3. And what we see is on this line you would have an open circle at negative 3, negative 6. And the rest of the line would be filled in. So when you have something that cancels, that does not give you a vertical asymptote, that gives you an empty circle on your graph. Still takes it out of the domain, but it does change the look on the graph a bit. Okay. Next I want to talk about the graphs themselves, and I do have a handout for you for that. So we may skip around on this handout a bit. I want to graph this function, x minus 1 over x squared minus 4. So step 1 is factor, top and bottom. So the top doesn't factor. X squared minus 4, how does that factor? Okay. Write it in lowest terms. Does anything cancel out? No, so we don't have any holes in our graph. This is reduced. So now we can start with our intercepts. X-intercepts. So x-intercepts are the x values where y equals 0. Okay, let's talk about that for a second. R of x is like your y. So to find your x-intercept, you're really just plugging in a 0 for your y. Now if you wanted to solve this, probably the first thing you would do is multiply over your denominator to get rid of the fraction. If I multiply that over, what's 0 times anything? 0. So really to find your x-intercept, it's just going to be what makes the top of the fraction equal 0. So if you want to work it out where you just set the whole equation equal to 0 and solve it, that's fine. If you remember that it's just really what makes the top 0, you don't necessarily have to show me all that work. So here we get our x-intercept at positive 1. So we could go ahead and plot that on our graph. We're going to touch the x-axis at 1. To find a y-intercept, you plug in 0 for all of your x's. It doesn't matter a bit if you do that in the original or the factored equation. So which one do you guys want to go with? The original, if I put in 0, I get 0 minus 1 over 0 minus 4. So I get 1/4. So I'm going to hit the y-axis at 1/4. Okay, vertical asymptotes. It's x equals what makes the bottom 0. So what would make this bottom 0? Look at our factored one. So we have 2. X equals positive 2 and x equals negative 2. When you graph those, they are just dashed lines. So we got that just by looking at our factored one and setting the denominator to 0. Now we need to decide if we have horizontal or oblique asymptotes. You can look at the original or the factored. I'm just going to go back to the original. What is the degree of the top? And the bottom? Okay, if the degree on top is smaller, our rule was it's horizontal, y equals 0. That's what we were doing last week. Okay, y equals 0, that is just the x-axis. Now it may seem a little odd that I have a point on that. What happens with graphs, they can cross a horizontal or an oblique asymptote in the middle. It's just the ends won't be. On vertical asymptotes, you will never cross anywhere. So we have found all of our information. Let's use our graph to help fill in the blanks here. So go to your y equals. And let's just plug in the original. You need to make sure when you put these in that you use parentheses around both the top and the bottom. So we can see when you're drawing it, if you draw something like this, I'm going to count it wrong. Because what's going on, these asymptotes, you have them marked on your graph. Those are lines that you should be getting close to. So you need to make sure as you draw this in, you are getting closer to these asymptotes. So it looks something like this. The middle section we see starts up here, comes down, hits our intercepts. Keeps going down, and then this last section is up here. So we have to find intercepts and asymptotes by hand and then use the graph to help fill in the blanks. And if your information doesn't match up, then go back and double check. You have a mistake somewhere. Questions do you guys have for me there? Okay, so let's keep building. We're going to do several. Let's look at this next one. What's step 1? Factor. X squared minus 1, how does that factor? Over our x. Okay, does anything cancel? No, so we don't have any holes in our graph. Next, we have intercepts. So x-intercept is when you plug in a 0 for your y. Or I told you that's really what just makes the top 0, because here if you just multiplied over your x, it goes away. So what do we get? -1 and positive. You set each of those parentheses equal to 0. So this one actually hits the x-axis twice. Y-intercept, if you plug in a 0 for your x, you get -1 over 0. Can you do that? So that means there is no y-intercept. This graph will not cross the y-axis. Next we go into asymptotes. So vertical asymptotes, x equals whatever makes the bottom 0. Right, on this case, the bottom is just x. So x equals 0 is a vertical asymptote. That's just the y-axis here. Horizontal or oblique? What's the degree of the top? And the bottom? So if the top is 1 bigger, that means oblique. To find oblique, we do long division. So this will be an oblique, so it should be y equals mx plus b. So my top was x squared minus 1. Denominator is just x. X squared divided by x is x. Multiply and we get x squared. Subtract those off so they cancel and we have 0x minus 1. What's 0x divided by x? 0, isn't it? So all we get is x plus 0. So our oblique is just y equals x. It's just a line. Y-intercept of 0, slope 1. We've found all of our information. Now we have to fill in the blanks. So you need to go to your calculator. I would just plug in the original. Make sure you put the numerator in parentheses. So x squared minus 1 divided by x. And so our graph, we know it hits these points. So we get something like this.
Teachers, in the next 2 minutes, pardon the interruption, the next 2 minutes, please check your email. Again, in the next 2 minutes, please check your email. Thank you.
Why don't you guys take a look at the next one and see how much stuff you can work through. Factor on this one. X-intercepts, when you set the whole thing equal to 0, or the shortcut is really just set the top to 0. So either way you want to do it. So you should get -1 for your x-intercept. Y-intercepts, you plug in a 0 for all of your x's. If you do that, you get 1 over 0 times 4. 1 over 0, that means there is none. Okay, asymptotes, vertical asymptote. X equals whatever makes the bottom 0. We're going to have 2 of them here. You guys are all giving me weird looks. Did I confuse you somewhere? On this? Because this is 2 terms. It's got something added with it, so you could only cancel it with another x plus 1. Other questions there? So vertical asymptote, x equals, since there's 2 things, you have to set each of them to 0, so x equals 0, and x equals -4. To decide horizontal or oblique, we need the degree of the top and bottom. Degree of the top would just be 1. The bottom, you have to think, if I multiply this out, I would have an x squared, so the bottom is 2. So that means overall the top is smaller, that means it's horizontal, y equals 0. So plot all this stuff. X equals 0. Be right here. X equals -4. Y equals 0. Okay, and then we use our calculator to fill in the gaps. I want to caution you on something. Your denominator, if you just type it in like this, you're going to miss it. You have to put another set of parentheses around the entire denominator to make it graph properly. So we should get, first section starts down here. Make sure it's a nice curve, getting closer to your asymptotes. The middle section looks like this. And then the upper section is right here. How are we doing with these? I would like to do at least one more problem. We might do a couple more, yeah.
Whenever it's like the one over here, right? Is it gonna go past?
It can. So it's kind of hard to tell from your calculator. So if you adjust your window, you might see. What I'm going to be looking for is the general shape. Now sometimes we will have them where they'll actually cross and they're going to get closer from the bottom side. So depending on your window, you might see slightly different things there. And I would accept either way. Other questions? Let's do, I'm gonna go to this one first, I think. So number 5 on your handout. What am I gonna have to do to factor the top? I can't do the shortcut because it's a 2x squared, so you actually have to draw out the box. So multiply to 4, add to -5. Get 2x minus 1, x minus 2. The bottom, x squared minus 4, would factor into what happens? So what happens right there? That means we have a hole in the graph. At the x value, what makes x minus 2 equal 0? 2. To get your y, you plug that 2 into what's left. So that would give me 3/4. You plot that on your graph just as an open circle, so I'll go ahead and put that there. Okay, now we move on with everything else. So our x-intercepts, you can go with your reduced one. Set this equal to 0. So multiply over your x plus 2. Add 1 divided by 2. We get 1/2. Y-intercept, if you plug in 0 for all of your x's, I'll just plug it in the reduced one. So 2 times 0 minus 1 is -1. 0 plus 2 is 2, so my y-intercept is -1/2. Vertical asymptote. X equals, what makes the bottom 0? -2. Now we have to decide horizontal or oblique, so that's based on degree. Degree of the top. You can do this either from our reduced or the original. If you just look at the original, the degree of the top is, and the bottom. So if they have the same degree, what do? You divide the leading coefficients for doing that. So it's horizontal. Y equals, so 2/1 is 2. All right. So now we can plot everything. We've got vertical at -2, horizontal at +2. Now we graph. Something I want to caution you on, these graphing calculators will not show you when there is a hole in your graph because it reduces before it draws the graph. So just keep in mind, it won't tell you that piece. You have to know yourself. So I'm just going to plug in the original. With parentheses. So we get this piece right here. And this one, make sure when you're drawing it, you don't accidentally make your open circle look like a closed circle. That one is still open. Questions there? All right, you guys tell me, how are we doing on these?
the interruption. In a minute, please check.
So you factor it, x minus 3's drop out, so that means you have a hole. If you were to plug 3 into what's left, you get 7/5, so that's an open circle on our graph. X-intercept is -4 if you set the top equal to 0. Y-intercept is 2 if you plug in 0 for your x's. Vertical asymptote, x equals -2 because that's what makes the bottom 0. Horizontal, if you divide leading coefficients, you can do it here or here, and you get y equals 1. So then fill in your graph, and it should look something like this. Are we okay with that? Then that is our stopping point. So we have 8 problems. What we are going to do, this is homework. I am probably not going to collect this until the end of class tomorrow because we didn't have very much time right now. So we are done with this chapter. I'm going to do a short quiz tomorrow, but I will do it towards the end of class. So that'll give you the beginning of class. We'll do some review. It's just going to be, I'm going to make it a very short probably 2 questions. One question like this, and one like the previous section where we were graphing the polynomials. So I will review that at the beginning of class tomorrow, give you some time to ask any questions on this homework if you need to, and then we'll do the quiz at the end of class. Sound good? But you've got a couple minutes right now to get started on this.